The difference between arithmetic reasoning and maths knowledge is arithmetic reasoning, it's maths applied to real life situation, right? So when you see a real life situation like this one, the first thing you need to ask yourself is, what is the story about? Next question is, which maths principle can be used to solve this problem? But before you know the maths principle that can be used to solve it, try to convert this story to either a mental picture or an actual drawing on your paper. So let's convert it to a drawing. Let's follow the story line by line. A boat travels 90 miles downstream in 3 hours. What does downstream mean? That's what you ask yourself, because there are two words here that are very important. Downstream, upstream. What's the difference?
Downstream is just like going down a hill.
Remember, it's a stream, not downhill, downstream. So downstream means, for you to go downstream, it means you're moving in the direction of the flow of the water, right?
Yeah.
So the water is flowing this way, and the boat is moving this way, correct?
Yeah.
Is it easier for the boat to move when it is going in the direction of the flow of the water?
Yeah, of course, because it's going down.
So that's why I can see that it went in a shorter time because it was going in the direction of the water, right?
Yes.
But in the second situation, the boat was going upstream. So this is the direction of the water. This was the direction of the boat. Is that an easy movement?
No.
So for the boat to go forward, it has to overcome the speed of the water or the velocity of the water, right?
Yeah.
The water is trying to push it this way and the boat is trying to go this way. So that process is going to slow down the speed of the boat, correct?
Yes.
So first thing we need to calculate is, what was the speed of the boat downstream? The speed of the boat downstream was 90 divided by 3, which gives you 30 miles per
Yeah,
hour.
it gives. Yeah.
Good. So that was the speed of the boat downstream. But the speed of the boat upstream is 90 divided by 5. What does that give us?
18.
So it gives us 18 miles per hour. So you can see that the boat moved faster downstream than upstream. But this speed that was generated going downstream is the speed of the boat plus the speed of the current, because they are both going in the same direction, right?
Yes.
So it created this, that the speed of the boat carried by the speed of the current, because we are moving in the same direction, gave us a speed of 30 miles per hour. But on the other hand, as the boat was trying to go upstream, it had to overcome the speed of the current in order to generate this speed. So the speed of the boat minus the speed of the current gives you 18. But the good news is, before you come across this kind of question in the Asvab, you should have already passed. So that's the good news. So before you come across this question, this kind of complex questions, you should have amassed the scores you need to pass. Okay, if you can get this kind of score, get this kind of question. In fact, if you can come across this kind of question in the Asvab, just start celebrating because you passed. Because you will not see this question at the beginning, right? So now they're asking us about the speed of the current. Remember when we did those two equations, system of equations, where we had to substitute into the second one?
Yeah.
Good. Can you remember how to solve the? Will you be able to solve this using that same process to find what C is?
So with this one, I can take with based on what we have on the screen right now.
Yeah.
I can take can minus 30 and 18 of them. I'll get 12. And then looking at the time difference, right?
Okay.
Based on upstream and downstream.
Okay.
Downstream was 3 hours and upstream is like 5 hours. So 3 minus 5 will also give me 2. And I will divide by the 12, but that will give 6.
Okay. And that's correct.
And that will be the current.
That will be the speed of the current. but let's solve it mathematically. So if we are looking for C, so we make B the subject of equation one. So C has to move this way. So we can say B is equal to 30 minus C. Is that correct? From this.
Yes.
So now we go to the second one, and where we see B, we are going to replace it with 30 minus C. So instead of having B, we're going to have 30 minus C is equal to 18. So we have 30 minus C is going to equal to minus 2C. So if you move 30 to the right, you subtract 30 from both sides, you're going to have minus 2C is equal to 18 minus 30, correct?
Yes.
18 minus 30 is going to give us negative 12. So negative 2C is equal to negative 12. If you divide both sides by negative 2, you're going to have C is equal to 6. That would be the answer. So the speed of the current is 6.
I think I came across some question like that yesterday somewhere, and I forgot.
Mm.
And I saw it. That's why I'm like, it got me confused a little bit. I'm like, okay, now I just have to take my time and read through it.
I think there's one other question that looks similar to this. Let me check it.